Chapter 2, Lesson 3 continued. Example 5 is the remainder theorem. The remainder theorem is a very useful theorem when we're dealing with algebra and our polynomial functions because it is an alternative way to evaluate a function at a given value. Okay. If we look at letter A, we have the polynomial function f of c equals 3x squared minus 2x to the fifth plus 4x to the fourth minus 2x cubed plus 8x minus 3. Okay. And we are asked to evaluate the function. I'm going to change this c to an x. There's a typo. When x is equal to 4. Okay. When x is equal to 4. So what I would typically do is I would replace all the x values with 4, and I would simplify. So this would be 3 times 4 to the 6th power minus 2 times 4 to the 5th power plus 4 times 4 to the 4th power minus 2 times 4 to the 3rd power plus 8 times 4 minus 3. Now, it's possible to calculate this, but it becomes extremely tedious and the opportunities to make mistakes are very high. Okay, so we have an alternative way to evaluate the function when x is 4, and that is with using synthetic division. Okay, the remainder theorem tells us that if we use synthetic division with the number that we are asked to evaluate x for, whatever number the remainder is the same value as if we were to evaluate the function as it is in front of us. So here's what this looks like. If I want to evaluate a function at x equals 4, I'm going to put 4 on the outside of the synthetic division. Now I'm going to list all of the coefficients of the polynomial function. It looks like it's of degree 6, so I have to make sure I account for every degree: 6, 5, 4, 3, 2, 1, and 0. So the 6th power has a coefficient of 3. The 5th power has a coefficient of -2. 4th power has a coefficient of 4. 3rd power has a coefficient of -2. 2nd power is not listed. I still have to account for it, so I'm going to put a 0 where there's x to the 2nd power. X to the 1st power is 8. And x to the 0 power is -3. Okay. Now again, when I use synthetic division, I always drop down the first number and I multiply the numbers at the bottom with the 4. So I'm going to multiply. 4 times 3 is 12, and I'm going to place that in the second column, and then I always add going up and down. So -2 plus 12 is 10. Then I multiply. 4 times 10 is 40. I add those values together. 4 plus 40 is 44. Now the numbers are going to start getting larger. I'm going to multiply 4 times 44. I get 176. You're going to have to use a calculator for this. And then I add -2 plus 176 is 174. Okay, multiply. 4 times 174 is 696. Add those together. 0 plus 696 is 696. And we multiply. 4 times 696 is 2,784. Going to add 8 and 2,784, and I get 2,792. Then I multiply. 4 times 2,792 is 11,168. And I add -3 plus 11,168 is 11,165. Okay. The very last number when I use synthetic division is the remainder. That means that did not divide evenly into the polynomial, okay, and that's what we had left over after we divided. Now the remainder is equivalent to evaluating the function when x is 4. So if I would have calculated this out by hand, I would have gotten 11,165. So f of 4 equals 11,165. Using synthetic division is a much easier process than evaluating that function using order of operations. I'm going to pause the video. I would like for you to attempt letter B and C. Once you finish B and C, I want you to hit play, and I want you to go through and check your answers. Okay, the answer to letter B, f of 6 is equal to 247,388. I think I wrote down the answer incorrectly. 388. Let me erase this here real quick. So I have my remainder right there, but then I wrote down 388. Okay, so what I want you to do is go through, check your work, make sure that you can come up with and get the following answer. Now for letter C, says the distance in meter that a person travels on skis can be modeled by the formula d of t equals 0.2 t squared plus 3t, where t is the time in seconds. Use the remainder theorem to find the distance traveled after 45 seconds. So what we want is we need to evaluate when t is equal to 45 seconds. So we use 45 outside of our synthetic division. When we look at our equation, it's to the power of 2. So to the second power, the coefficient is 0.2. The first power, the coefficient is 3. We also have to account for our constant, which is the 0 power. Since it's not there, I put 0. I drop down the 0.2. I multiply 45 times 0.2, and that's equal to 9. Add 3 and 9 to get 12, and I multiply 45 times 12 to get 540. So in 45 seconds, the skier can travel 540 meters. Now, the remainder theorem in evaluating a function using synthetic division is also called synthetic substitution. Okay. So up here at the top of the page, you may want to put synthetic substitution. Sometimes we'll refer to this as the remainder theorem. Sometimes we'll ask you to evaluate using synthetic substitution, in which we recommend or actually require you to use synthetic division.